students, today's agenda is to check homework. We'll be graphing rational functions with oblique asymptotes, and you will be able to do 7.8. Today, students will be able to graph rational functions with oblique asymptotes. And we have learned about vertical asymptotes. We'll go over that again today. And we have learned about horizontal asymptotes, but for that one, it follows 3 different rules. And so basically today we're going to be doing this one with oblique or slanted asymptotes. And we are going to go over these ones with a specific example, but just to review, vertical asymptote is when you make the denominator equal to 0. An asymptote is a line where my graph will approach it, but it will never touch it. Again, it will make sense when we'll continue to see that. Okay, for the horizontal asymptote, we have to check the degree and the leading coefficients. And here I have some examples just to find that horizontal asymptote. Remember me, when the degree is smaller on the top. So in here we have a 1, in here we have a 2. Or even if there is no x, that means x to the 0. So that's still, they call it heavier in the denominator, bottom heavy, okay? The rule is that the asymptote will always be y equals 0. Y equals 0, okay? Again, if the numerator's degree is less than the denominator's degree, then y is going to be equals to 0. The second possibility is if the degree in the numerator and denominator are exactly the same, what you do is divide the coefficients to find that horizontal asymptote. For example, in here we have 1 divided by 1. So my asymptote will be y equals 1 divided by 1, which is equals to 1. Same if you had a 3 and a 1 in here, 3 divided by 1, it will be 3. Or if you have a 4 and a 2, like in this case, if this will be quadratic for both of them, you just divide 4 divided by 2, and that will be 2. Again, when the degree is the same, you divide the coefficients to find the horizontal asymptote. Finally, which is going to be the case for this lesson, is that when it's top heavy, it's heavier on the top, meaning that it's greater, the numerator's degree, the degree in the numerator is greater, then we're going to divide the entire expression in the numerator, divide that by the denominator, and the answer will be the equation for my oblique asymptote. So they say if this is greater than this one, there is no horizontal asymptote, so it becomes a slanted. Okay, so no horizontal asymptote, so we divide the numerator by the denominator, and that becomes the oblique asymptote. Okay, so those are the 3 options. We have seen videos, the previous lessons have been focused on these ones, but now we are going to be doing one with oblique asymptote. Okay, in 7.7, we started multiplying and dividing expressions to have them in both factored and standard form. And so that's what we're going to be doing here. We have it in factor form. We need also the version in expanded form. So remember that FOIL, it means multiply first. So that's the first will be x times x is x squared. Then outside will be these ones. I like to do it directly in here. So the outside terms will be x times negative 2 is negative 2x. And the inside is the 2 inside. So 3 times x is 3x. And so together, instead of combining them in here, I just add them directly. So 3x minus 2x is positive x. And last is the last terms on each parenthesis, so 3 times -2 is -6. And for the denominator, we don't have to do anything. I'll just bring it over. So we said that for the vertical asymptote, you just make the denominator equal to 0. So to find my vertical asymptote, I'll just make x plus 1, that's the denominator, equal to 0. And I start solving. If I'm adding 1, the opposite is to subtract 1. And so x equals -1. So the vertical asymptote is -1. That's on x, -1 right there. And I just put my vertical asymptote through that. It means that my graph will approach this line, but it will never cross it or touch it even. Okay? For my horizontal asymptote, well, we go to our rules, and I intentionally chose this one right here, x squared plus x minus x divided by x plus 1. Since it's top heavier, or it's heavier on the numerator, then there is no horizontal, so we have to divide to find the oblique asymptote, okay? So we say that there is no horizontal asymptote, and so we find the oblique asymptote. And so how do we do that? We have learned in the past synthetic division, but if you don't remember it, we write the coefficients. If there is no coefficient, that means that there's a 1 in there. So that's what we're going to write in here, 1, 1, and -6. The coefficients and the constant right there, leaving a space over here. Since we have in the denominator x plus 1, we get the opposite of whatever you're adding or subtracting, so -1. And then we start multiplying. But first, the first term, you always bring it down 1, and now you start multiplying. So -1 times 1 is -1, and you put it on under the next one. We combine that, and 1 minus 1 is 0. Again, we multiply. -1 times 0 is 0. And combine those, -6 plus 0 is -6. We have a remainder, but we ignore it. So the answer would be 1, but we don't put the 1. And we look at whatever we're dividing, we put the next degree, the next exponent. So if this was a 2, we put an exponent 1. Again, we don't need to put that in there. The next is 0. We don't need to put 0. So in reality, what we do is plus or minus, it would be in this case, negative over whatever you're dividing. That's kind of like a remainder. So, but we ignore this part right here, and what we're going to be graphing for our oblique or slanted asymptote is y equals x, ignoring whatever is the remainder, okay? So in here, it means that we start at 0, right? The initial point is 0. And then the slope is 1 over 1. The rise is 1, the run is 1. And here is 1 over 1. So 1 up, 1 to the right. 1 up, 1 to the right. 1 up, 1 to the right. And so that's going to be my slanted or oblique asymptote. Now that we have our vertical asymptote and our oblique asymptote, that means that my graph will be either here and here for this rational expression, or it might be here and here. What can guide us? We can either do a table, or we can find some specific points like the x-intercepts and the y-intercepts like we have done in the past to find those. So what we're going to be doing in this lesson is we will do both. Let's find the x and y-intercepts to guide us if the graph goes here, here, or here and here. Okay, so let's find the x-intercepts and y-intercepts just to guide us on where that would be. But then at the same time, we will check with specific points, like we have done in the past. So let me take advantage of all this space. For the x-intercept, y will be 0. So for the x-intercept, y will be 0. For the x-intercepts, it's easier if I have it factored already. So I'm going to put 0 for y and then equal to all that expression. So x plus 3 times x minus 2 divided by x plus 1. How do we solve this? Well, if we're dividing, the opposite is to multiply, and we do that on both sides. This cancels, and 0 times anything will always be 0. And look at that. You get x plus 3 equals, x plus 3 times x minus 2. Now, when we have it in this factor form, remember that what this means is that one of the factors have to be 0, because 0 times anything will be equal to 0. And what can make this 0? Well, x would have to be negative 3, because negative 3 plus 3 is 0, so negative 3 is one possibility. Or if we want to make the second one 0, then this would need to be positive 2, because positive 2 minus 2 is 0, and 0 multiplied by, in this case, if it's a 2, that will be 5. 0 times 5 is 0. And 0 times 5 will be 0. In other words, just get the opposite, if you notice. Okay, so we have our x-intercept, which is negative 3 for x and 0. And the other one is positive 2, 0. Negative 3, 0. Negative 3, 0 is right there. That means that my graph is going to be here. And for that matter, it will also be on this side. The other one is 2, 0. So 2, 0 is right there. Let me enclose that. Now for my y-intercept, x will be 0. And for this one, you can choose the same, whichever. I'll choose this one, but if you want to, you can also replace that and it will give you the same answer. So y is equals to 0 squared plus 0. I'm just replacing x with 0, minus 6 divided by 0 plus 1. And so in here, 0 times 0 is 0, plus 0 is 0, minus 6 is negative 6. 0 plus 1 is 1. And so my y-intercept is at 0 for x. And y is negative 6 divided by 1 is negative 6. So we go to our graph, and 0, negative 6, 0, negative 6 is right there. So now that we have those points, this can guide me, and basically if the teacher is not asking for more or for specific points, you can just say, oh, this graph goes through here, it'll approach those two asymptotes, but it will never touch it. One other thing, in the previous lesson we learned about removable discontinuities or holes, but in here we didn't cancel any factors. Those holes are only there if we had canceled, like if we had x plus 1 in here and we cancel, those become holes. We don't have that. So let's do it with pencil very lightly so that we know that this graph approaches but never touches those asymptotes. Okay. Now, how do we choose if your teacher or professor asks you for specific points? Well, first of all, I would choose the vertical asymptote. The value is -1, and I will probably need at least 3 other points, so I would put it right there. The vertical asymptote is at -1, put -1 in here. Then I would add and subtract half, okay? So in here I would put -1/2. After that I would put 0 and then +1. Now you wish, you can choose, instead of choosing these 2 points, you can just choose any other point in here. Maybe do like 6 to see where it goes. That's fine. Okay, on the other side, you get negative 1 1/2, negative 2, and maybe negative 3. Or again, you can decide to choose instead of this big one, instead of negative 3, especially since we have it already, maybe choose like negative 6 or something. I don't know. Let's do that. Negative 6. And so what you're going to do is you're going to replace these values in any of the two expressions. It can be the factored or the standard form, okay? And so let me rewrite it in here. Let me use the expanded form. So x squared plus x minus 6 divided by x plus 1. And so for the first one, you will have y is equals to 1. We're replacing the value of that I chose in here in x. So x squared is 1 squared plus 1 minus 6 divided by 1 plus 1. 1 squared is 1 plus 1 minus 6. 1 plus 1 is 2. And so in here we have 1 plus 1, 2, minus 6, negative 4, divided by 2, which is equals to negative 4 divided by positive 2 is negative 2. So I have negative 2 for the first value. And I'll just use a different color so that it doesn't get confusing. So 0, 0 squared, plus 0 minus 6, 0 plus 1. 0 squared is 0, plus 0 is 0, minus 6 is negative 6. 0 plus 1 is 1, and negative 6 divided by 1 is negative 6. We had that one already, 0, negative 6. For the next one, negative 1/2 square. The negative, it's included in the squaring, plus negative 1/2 minus 6 divided by negative 1/2 plus 1. In here, negative times negative becomes positive. 1 times 1 is 1. 2 times 2 is 4. And positive times negative becomes negative 1/2 minus 6. In here, if we have negative 1/2, that means I owe half of $1, but I have $1, then that means that I have positive 1/2. And in here, you might want to use your calculator and start working with decimals. That's perfectly fine with me. But you might want to ask your professor what he or she will prefer. And let me show you how you would do it. 1 divided by 4 minus 1 divided by 2 minus 6. And this I can do only because this calculator will respect the division going on between the minus before, because it's a scientific calculator. Negative 6.25. Then we have to divide by 1/2, which is 0.5. And you get negative 12.5. Now let's see, which would be negative 12.5, okay? So let's see how you would do that in here. So what we can do is make all of them into fourths. Just the numerator, because in division you don't really need to have a common denominator, only subtractions and addition. And so in here you will multiply by 2, because 2 times 2 will make it into fourths. So you have the 1/4 in there, minus 2 times 1 is 2, and 2 times 2 is 4. And then this you need to multiply by 4, but at the same time the numerator as well. So why? Because we need the denominator to be fourths. So minus, because of this, and then 6 times 4 is 24. 1 times 4 is 4. And now we have a common denominator we can add and subtract. Be careful because this is positive. Okay, so that means that negatives, I have negative 26, but 1 positive, we subtract that and leave the greater sign. So it's negative 25 fourths. Divided by 1/2, we just carry that We didn't change it because in division we don't need to change it. In here, what we do is just multiply like that. The outer, we put negative 25 times 2 is negative 50. 4 times 1 is 4. And if we divide, how many times does the 4 go into 5? Well, first, negative divided by positive is negative. How many times does the 4 go into 5? 1. And you have 1 left. How many times does the 4 go into 10? 2. 2 times 4 is 8, and you have 2 left, 2/4, which is equals to, if we simplify that, 2/4 become 1/2. So negative 12 and 1/2. If this got confusing, just do it with a calculator. That's fine. So negative 12 and 1/2. For the 1, y is equals to negative 1 square plus negative 1, which is minus 1, minus 6 divided by negative 1 plus 1. Negative, in here, in the denominator, we get negative 1 and positive 1 is 0. We cannot have a 0 in the denominator. That immediately means that the answer will be undefined. But if you want to continue, that's fine. Negative 1 times 1 is 1. Positive times negative is negative 1 minus 6. So 1 minus 1 is 0. So it's negative 6 divided by 0. Again, we cannot divide by 0. Negative 6 divided by 0, look at what the calculator says. Divide by 0 is equal to error. There is an error. You cannot have that. So we just say undefined. And that's why we have that asymptote, because there are no values for that. That's what the asymptotes are. It says there are no values in these two lines. Okay, for the next one, I'm just going to work with decimals, but you can always convert it to 2 times 1 is 2 plus 1 is 3, negative 3/2. Okay, you can work with negative 3/2 for the values of x. So negative 1 and 1/2 is negative, y equals negative 1.5 square plus a negative, I forgot the negative, plus negative 1.5 minus 6 divided by negative 1.5 plus 1. Negative 1.5 squared. And in fact, because we're using our calculator, I hope you can see it. Let me just move it to the side instead. So we open a parenthesis. We put negative 1.5, close the parentheses, and then square will be that button right there. Right there. Okay, square it. Then positive times negative is negative, or you can put plus, open parentheses, negative 1.5, but it's better, yes. Positive times negative, negative or minus 1.5 minus 6. Why in here I use minus is just because after I multiply the positive times negative, it just becomes a subtraction. And we don't have something else going on with that number. That's why we don't need that parentheses. But if you want, you can again put it plus, open a parenthesis, negative 1.5, close parenthesis, minus 6. Okay, and we get negative 5.25. In here, negative 1.5 plus 1, we just cancel the negative and the positive 1, and we get negative 0.5. Again, if you need to see it in here, negative 1.5 plus 1 equals negative 0.5. Finally, negative 5.25 divided by negative 0.5 equals. The answer is 10.5. So 10.5. And that's positive because negative divided by negative is positive. The 2, I already know the value because it's one of those x-intercepts, so that will be 0. I'm not going to do it. is the x-intercept. Okay, and for the last one, -6, that's the one that we chose. Okay? So it's -6 squared. Because it's negative, that's why we're putting the parentheses, plus -6 minus 6, -6 plus 1. All we're doing is replacing the x value. -6 times -6 is positive 36. Positive times negative is -6. Bring down the -6. -6 plus 1 is -5. And so in here we have 36 minus 6 is 30. Minus 6 is 24. Divided by -5. Positive times negative is negative. How many times of the 24? Well, you can do fractions, or you can just divide 24 divided by -5. And the answer is -4.8. If you were to do it as a fraction, how many times does the 5 go into 20? It goes 4. And then you have 4/5 left. Okay, so -4/5, -4.8 is the same. So -4.8. Now let's check these points in here. Because we already have the graph, but 1, -2. So in here we have 1, -2. My graph would go through there. So I'm a little off. And that's why sometimes you might be asked to do specific points to make sure that you're going through the graph correctly. 0, -6, we have that already. -1/2, -12.5. -1/2, -12.5 will be, well, in here I have 10 points, 10 squares. So 12.5 will be somewhere in there. So that's how my graph would actually go. And again, you might want to choose points in here to see where that goes, but otherwise it's just a sketch. On the other side, you have, and when you have -1 undefined, that's because you have the asymptote. That means that there are no points on that line. -1.5 is 10.5. So -1.5 is 10.5. So it's around there. -2 is 0. -2 is 0 right there. We didn't do the process for that one. And -6, -4.8. -6 will be 2. So 2, 4, -6, -4, and 0.8. Ooh, wow. Okay, so that's my graph right there. We're very close to what we had graphed. So that's why those points are just there to check, to make sure that you're going. And I don't know if you saw that I went there with the 10. So -1.5 is 10.5, -1.5, and then 10.5, around there. Now, I would like to take this moment to extend an invitation to visit us at Math Maria 7 for fun encounters with math. If this has been helpful, if you can share with others so that they would also benefit from watching these videos. Don't forget to subscribe and hit the bell so that you can get notifications when there is a new video. If you can please give us a thumbs up. Here is where you can subscribe. This is the link to the entire unit on graphing rational. You will find the latest video. Now you're able to do 7.8 and have fun.